So today we're going to be talking about another way that you can solve quadratic equations. So far you would have learned how to solve quadratic equations by factoring, and then you would also have kind of learned how to solve them by graphing and looking for where it crosses the x-axis. Today you're learning another way that you can kind of accomplish the same goal of solving a quadratic equation. Today you're going to learn about how to solve quadratic equations using what's called the square root method, okay? So just like in order to solve by factoring, it has to be able to be factored. And then to solve it by graphing, you have to be able to see where it crosses the x-axis. To be able to solve it using the square root method, you have to have certain things happening, okay? So this method can only be used, so you're only going to be able to use the square root method if either you're missing the bx term when it's in standard form. So just kind of refresh your memory. Standard form is y equals ax squared plus bx plus c. So if it's in that form, you actually have to be missing that x term right there. It cannot be in there, because if it was in there, you wouldn't actually be able to solve it this way. So that term has to be missing, okay? So if that's missing, then you'll be able to use the square root method to solve it. Or if you're looking at the equation and it ends up being in vertex form, you'll actually be able to solve it this way as well, okay? So we're going to do some of those examples, but just to kind of review vertex form, it's y equals, you've got a number up front, and then you have in parentheses x minus another number, and then remember those parentheses have to be squared. And then you're going to be adding or subtracting a number on the outside, okay? And then remember, the only reason why the reason why this is called vertex form is because if you take this number out and you change the sign of it, and then you take that one and put it in like a coordinate, so if I take that one and change the sign and then I just copy that one down, that is your vertex. So that's the reason why it's called vertex form, okay? So one of two things has to happen in order for you to use the square root method to solve your quadratic equation. You either have to be missing that x term if it's in standard form, or it has to be in vertex form, okay? So if either one of those is happening, then you'll be able to solve it using the square root method, okay? So what I've done is I wrote down what the steps are that you would take to solve it. And what we're going to do is kind of use these steps to help us do some examples here, okay? So just to kind of run through the steps so you know what they say, the first thing that you're going to do to be able to solve it using this method is you have to get whatever the squared part is by itself first, okay? So whatever's being squared, you've got to get by itself, so everything else in the equation has to be on the other side of the equals. Once that's happening, then the opposite of squaring something is square rooting. So to get rid of the square, you square root, because remember, you're trying to get it to where x is by itself. So you got to get the squared part off. So you're going to square root, and then you have to do it to both sides, because what you do to one side of the equation, you got to do to the other to keep it balanced. And then one thing that you're going to have to remember with these, and we'll talk about this part in a second, is after you take the square root, you're actually going to have two answers that will work as your x value, okay? And so what you have to remember to put anytime you take the square root is a plus or minus, okay? And then sometimes you'll have to solve the problem after that. So you'll notice I put, you're going to solve it if it's needed or if it's necessary, okay? So let's do some examples so you can see how to solve quadratic equations using the square root method, okay? So this first example, you've got x squared equals 16, and it's going to say something like solve that equation, okay? Well, you're going to look at that equation to begin with, and you're going to ask yourself, are either of these happening? So if you kind of quickly glance at that, you can tell that it's not in this form. So that's not happening. So then look at it when it's in this form. Well, you're not going to usually have your y whenever you're solving equations. Usually it's going to equal some number. And so I'll just put like equals 0 because usually that's what it'll equal, okay? But you're going to look to see, are you missing the bx term? So you're going to look and you're going to say, kind of say to yourself, do you have an x term in there? And notice you have an x squared, so that's kind of like this part, but you don't have an x. So that's actually a good thing because you want to be missing that term to solve it. So you can actually use the square root method to solve it. So let's run through these steps. So, and before I actually go through the steps, just think about what you're actually doing here. When you're solving, you're trying to find an x value that if you plug it in here, it'll work in that equation. So you could probably think through this one and figure out what could I plug in for x that when I square it, in other words, when I take it times itself, gives me 16. So you could probably figure that out. Okay, but you could also do it this way. So that's what I'm going to show you. Okay, so the first thing is you get whatever is being squared by itself. So if I look, my x is being squared. And so if I look at that side of my equal, so like if you need to put like a little wall to kind of see the separate sides of your equation, you can. But if I look at that side of the equals, that's the part that's being squared, and there's nothing else on that side with it, so that part's already being done, okay, or it's already been done. Then, to actually do the solving part, we have to get rid of the square because we want to get the x by itself. So the opposite of squaring is square rooting. So you're going to square root that side so that the square will go away. Now what you do to that side, though, you have to do to the other side. So keep it balanced. Then when you do that, the square root and the square are opposites each other, so they'll cancel each other out. And then you'll be left with x on that side. And then you have to ask yourself what the square root of 16 is. This is actually where this part comes into play, okay? And I'm going to talk to you about why that is. So I'm going to rewrite that equation we had. So before I had said you could actually figure this one out, and you can think about, you know, what numbers, if I square them, would give me 16. And if you think through it, you would realize that if I take 4 and I square it, so 4 squared, 4 times itself, 2 times, gives me 16. But there's actually another number that if I take it times itself will give me 16. And if you think hard and long enough about that, you'll figure out that if you take negative 4 times itself, so in other words, negative 4 times negative 4, you actually end up getting 16 out of it. So the reason I say that is because when you do this and you solve and you end up taking the square root like you did here, you actually will have 2 answers. You're going to have a positive answer and a negative answer that would work for that, okay? So the square root of 16 is 4, but you have to put plus in front of it to represent that 4 would work, but then you also have to put a little negative in front of it to show that negative 4 would also work in that equation. So this is one way to write that. But the other way that you could write it is this is the same thing as saying technically negative 4 would work and 4 would work, okay? So this is just a shorthand way of writing that, okay? But they're the same thing, all right? So we didn't have to do that last step in this one just because once we square rooted, the x was already by itself, and then we ended up with our answer. Okay, and then remember, this is kind of relating it to the other stuff we talked about. This would be where that parabola, when you graph it, crosses the x-axis. So if you were connecting it to the graph, it would cross the x-axis at negative 4, and then it would cross the x-axis at 4. And then if you were trying to figure out which way it opens, you'd have to get it equal to 0, but the number in front of x squared is positive, so that would mean that it opens up. So that's kind of a rough sketch of what that graph would look like, okay? So let's do some more. So let's say that you were trying to solve this problem, all right? Well, if you're wanting to use this method, you have to have one of these 2 things happening. So when I look at it, it's not in vertex form. So, well, it looks like it actually might be in standard form. So I have to double check and make sure I'm missing my x term. And if you look down here, you have the x squared, and then you have like the number that's by itself, but then you don't have the x term. So that means that you're missing that bx term. Okay, so then you can use this method. All right, so let's do it. You got to get the squared part by itself first. So when I look at my equation, there's my equal. So if you wanted to draw a little wall to separate your sides, you can. I'm going to look at the part that's being squared. So my x is the thing that's being squared. I actually notice that I have something on the same side as the thing that's being squared. So I have to move this to the other side so that it's no longer with the part that's being squared. So to move that, remember you do the opposite. So the opposite of subtracting 90 is adding it. So you do that to both sides. So negative 90 plus 90 is 0, so those go away, which is what you want to happen. Your x squared comes down, and then you add these, so you got 0 plus 90, which is 90. And then from there, well, you got to get this square away. So we've got the squared part by itself. Now to get rid of the square, you square root, because that's the opposite. So you square root, and then what you do to one side, you got to do to the other. And so the square root and the square will cancel, and you'll be left with x. And then it's going to be, remember, whatever you get here, there's actually two answers that work. So you have to put plus or minus in front of it, and then you're going to get your answer. Now, if you look at this, that is not a perfect square. So it's not going to end up as nice as that one did up here. So then how do you deal with that? That's actually what we worked on the other day. So when it's not a perfect square, remember you go to the side and you break it down into the biggest perfect square that'll go into it, and then what multiplies times that to give you that number. So what is the biggest perfect square that goes into 90? And if you kind of start dividing it by all your perfect squares, you'll realize that the biggest one that goes into it is 9. And then what do I take times that? That'll give me 90. So if I take 10 times 9, I'll get 90. So you broke it down. Now you can actually take the square root of this. So the square root of 9 is 3. And then that square root 10 just comes down, because you'll end up getting a decimal if you try to type that in. And you don't want a decimal for these. You have to be able to write it in simplest radical form, which is what this is called. So that's what you get. So your answers, the x values that would work in this equation if you went back and plugged them in, would be positive and negative 3 square root 10. Okay, so you could write your answer like this, or remember, kind of like what I talked about up here, you could write it separately if that helps you make better sense of it. But you would say negative 3 square root 10 and positive 3 square root 10 would work in that equation. Okay, so you could write it either way. All right, so let's do another one. What if we had something like this? Same steps as before. You've got to get the squared part by itself. So I'm going to look at my equation. I'm going to look at what's being squared. So now you're going to want to say that that 4 is being squared as well. But if you kind of look at it, that 4 actually has its own little exponent. It's got an exponent of a 1. Okay, so that 4 is not being squared. The only thing that's being squared over here is the x. Okay, so my goal is to get the x squared by itself. So that means I have to get this 8 to the other side, but then I also have to get that 4. So when you're adding or subtracting, you actually start with that part to move it to the other side. So to get this positive 8 to the other side, I would do the opposite, which would be to subtract it. So 8 minus 8 is 0. And then I end up with 4x squared on this side. And then on this side, I have 0 minus 8, which is negative 8. Then from there, I have to divide by 4 because I'm multiplying by 4. So you divide by 4 on both sides. 4 over 4 is 1. And then I'm left with my x squared, which is what I was trying to make happen. And then this will simplify. Negative 8 divided by 4 ends up being negative 2. Okay, so then from there, once you get the squared part by itself, then you have to get rid of the square. So the opposite of squaring is square rooting, and then you have to do that to both sides. So your square root and your square will cancel. And then from there, You're left with x. Now, notice we have another dilemma here. Well, we talked about the other day, what do you do when you end up with a negative under a square root? So anytime you have a negative under a square root, the way that you think about that is that's like a square root of a negative 1, and then you have the square root of 2. So when you have a square root of a negative 1, that's actually I. So that's how you write that when you have a negative. And then you see, does that simplify? Square root of 2 will not simplify. So you actually just bring it down, okay? The other thing you have to remember is when you take the square root of both sides, you have to put your plus or minus. So you got plus or minus, and then you have I square root of 2, okay? So that is as simple as that one will get. So there's that one, okay? So then let's do another one. What if we had something like this? Well, same steps. You've got to start by getting the squared part by itself. That one's being squared. So I want to get this to the other side. So I would subtract it. 36 minus 36 is 0. Your x squared is by itself now. And then 0 minus 36 is negative 36. Then, well, to get rid of the square, you square root. And you have to do that to both sides. So the square root and the square will cancel. Your x comes down. And then, same story as before. When you have a negative under a radical, that's going to give you the I. And then you figure out what is the square root of 36. So you can kind of break it down if you want to kind of think through it. So you got the square root of negative 1. That's how you pull out that negative. And then you have the square root of 36. So the square root of the negative 1 is the I. That's the complex number. And then the square root of 36 would be 6. So when you multiply them, remember you put that number in front of the I. And then the other thing you have to remember is because you've taken the square root of both sides, you've got to put your plus or minus. So that would be your answer there. Okay? All right, let's do a couple more. What if you had something like this? Look at the part that's being squared, get it by itself. So I'm going to have to move this over there and move the 4. So start with the adding and subtracting part. So the opposite would be to add 81. So negative 81 plus 81 is 0. And then I just bring down my 4x squared. Then 0 plus 81 is 81. Okay, and then from there, I've got to divide by 4. So you divide by 4 on both sides. And then you're left with x squared equals, and then 81 divided by 4 is not going to give you like a whole number because these won't reduce to be a number other than a decimal. And so, well, what do you do there? Well, you could see if there's a number that goes into both of them evenly, but if you kind of look ahead, think about what you're about to do here. You're about to square root. If you look at these are both perfect squares. So I'm actually going to just kind of bring that down. And I'm going to go ahead and take the square root. So when you square root, you got to do square root both sides like we did the other problems. The square root and the square will cancel because they're opposite. And so you will be left with x. And I'm going to just write it over here. So we're left with x. And then the thing that you can do when you have a fraction under a radical is you can actually break that down to go with the top and the bottom, okay? And then the other thing that we need to make sure we put is, remember, because we took the square root, we have to put that plus or minus in front of it, okay? So let me scoot my x over here so that it's not all crowded. Okay, so it's going to be plus or minus whatever we get here. Well, let's figure out what this is because this will actually break down. So I'm going to just carry my plus or minus over, and then I can take the square root of each one. What is the square root of 81? Well, what times itself gives you 81? 9. What is the square root of 4? Well, what number times itself gives you 4? It would be 2. So notice it kind of simplifies kind of nicely. Now, it's not going to simplify all the way, but this would be your answer, positive or negative 9/2. That would be the x value that if you plug it into that equation would work in that equation. All right, so this one. Same steps. You start by getting the x squared part by itself. So I've got to move that negative 3 over. I've got to get that 5 away. And then that squared part will be by itself. So to get the 3 over there, I've got to add it. Negative 3 plus 3 is 0. I have 5x squared on this side. And then I have 4 plus 3, which is 7. And then from there, got to divide by 5 on both sides. So that goes away. And then my x squared comes down. And then I have 7 over 5. So once I got the squared part by itself, I square root both sides so I can get rid of my square. So my square root, my square will cancel. And then I have x on this side. And then remember, you've got to put plus or minus because we took the square root. And then it's whatever square root of 7 over 5 is. So just like what we did in the last problem, you can break it between the top and the bottom. But you're going to notice this one's a little different because these don't simplify like the other ones did. So what do? Well, one thing that you will learn with radicals is you cannot have a radical on the bottom of a fraction. So because we have a radical on the bottom, what you're going to do is you're going to multiply by that radical on the bottom, but then you also want to do the same thing to the top so that it'll keep kind of the fraction balanced. And what you're really doing is essentially multiplying by 1 because it's the same number over the same number essentially, okay? And so when you multiply on top, and I'm just going to bring my plus or minus over, on top you multiply the inside numbers, so 7 times 5 is 35, so it'd be the square root of 35 on top, and you leave it under the radical because you haven't actually taken the square root yet. And then on the bottom you'd have the square root of 5 times the square root of 5. So what's 5 times 5? Well, that would be the square root of 25, and then what is the square root of 25? You get 5. And so that's the whole reason you multiply by that same radical, is to make the radical go away. So, and then you check, does this break down? And notice there's not a perfect square that goes into 35. And so that is actually as far as you can go. So that would be your answer for that problem. Okay? So that is how you do problems that are kind of like in standard form and you're missing the bx. So now we need to talk about, well, what happens when it's in vertex form? Okay? So you're going to notice that the steps are the same, but then these are the problems where you have to actually solve. Okay? So I'm going to flip to the back because I have a couple examples on the back. All right? So notice number 7, you've got one, and it kind of looks like it's in vertex form because you've got like a parentheses that are all squared, and then you have plus or minus a number, okay? So that's kind of how you know it's in that form. So the steps will kind of be the same. Remember that first step is to get the squared part by itself. So we're going to still do that. So notice you've got all of this being squared, so that's the part we want to get by itself. So if you look, you've got a plus 8 over here. So the first thing you want to do is get that 8 to the other side of the equals. So I did the opposite. So I'm going to bring down my x plus 4 squared, and those went away. So that's the only thing that's left there. Then you take 12 minus 8, which is 4. So now notice your squared part's by itself. Once you get the squared part by itself, think about the next step. You square root. So you have to square root so that you can get rid of the square, and then remember you have to also do it to the other side. So the square root and the square are opposites each other, so they cancel, and then you're just left with whatever is underneath the radical, which ended up being x plus 4. Now the other thing that you cannot forget is to make sure you put that plus or minus. Because remember, you square rooted, so you cannot forget to put plus or minus and then write your answer. So what is the square root of 4? Well, you get 2. So the reason why you cannot forget that is because with these problems, you're going to notice you have to actually do a couple extra things to get your answers, okay? So like if you compare that to the problems we did on the other side, once you kind of took the square root, you already pretty much had your answer. Sometimes you had to simplify a little bit, but you pretty much already had your answer. But for these, you're going to have to actually solve from there, okay? So I'm going to show you what to do once you get to this part, okay? So don't forget to put your plus or minus. But if you remember what I talked about before, the reason why you put your plus or minus is because this kind of represents two different numbers that would work. So what you have to do from here, because it's not just x equals that, is you have to actually kind of break this down into two things, because this is kind of like saying x plus 4 equals positive 2, but it's also the same thing as saying x plus 4 equals negative 2. So you have to split it up into an equation that factors in the 2, the positive 2, and then you have to write that same equation but equal it to the negative 2 as well, okay? Because you're going to end up with two different answers, and that's how you find them, okay? So to solve this one, well, we think about it like a normal equation. I have to get my x by itself, so I'm going to have to subtract my 4. So when I do that, 2 minus 4 ends up being negative 2. So there's one of my answers. And then to solve this one, same thing. To get to x by itself, I'm going to have to subtract 4. So 4 minus 4 is 0. So I have x. And then here I had the negative 2, so it'd be negative 2 minus 4, which is negative 6. So with these problems, you just have to remember to put the plus and minus, and then you separate it into one equal to the positive answer and then one equal to the negative answer. Okay, so let's do one more of these. All right, what if you had a problem like this? Well, notice you have kind of a parentheses and it's got some stuff in it squared, so that's kind of like the vertex form. So you'll be able to solve it using the square root method, but you've got to get the part that's squared by itself. If you look, the part that's being squared is the x plus 2. So what I'm going to have to do is get this negative 3 away from that side. So if you look kind of between them, there's nothing between them, which means technically you're multiplying. So to get that negative 3 away, I actually have to divide by negative 3, and then you have to do that to both sides. So negative 3 divided by negative 3 is 1, so those go away. And then you're left with x plus 2 squared. And then 36 divided by negative 3, well, a positive divided by a negative is a negative. And then 36 divided by 3 ends up being 12. Okay. Then, well, we've got our squared part by itself, so you got to get rid of the square. So the opposite would be to square root. And then you have to do that to both sides. Okay. And so the square root and the square will cancel, and you'll be left with x plus 2. And then remember, you cannot forget to put the plus or minus, and then you write your answer. So that's one where we're going to have to go to the side and break it down. So notice you got a negative, so that's like the square root of negative 1, so that's your I to bring out the negative. And then you've got the square root of 12. Well, 12 is not a perfect square, so that means you have to actually break that down. So find the biggest perfect square that goes into it. Okay, well, if I just start dividing that by perfect squares, I'll figure out the 4 goes into it, and it goes 3 times. So then when I simplify this, square root of 4 is 2, and then my square root 3 comes down. Okay, so now putting these together, well, remember, you put the outside things together, so the 2 and the I go up front, and then remember you put the I kind of behind the whole number. And then that square root 3 just kind of hangs out in the back. All right, so you've got plus or minus 2i square root 3. All right, now because the x is not by itself, that's where you had to separate it into its two parts. You have to make it equal the positive answer, and then you have to make it equal that negative answer. So we got x plus 2 equals positive 2i square root 3. And then you have x plus 2 equals negative 2i square root 3. Okay, so get the x by itself. So to get the x by itself here, I've got to subtract 2. So 2 minus 2 is 0. And now these are actually not going to combine because they're not like terms. Like this is what's called a complex number, an imaginary number, and then that's a real number. So when you have a real number and a complex number together, you put the real number first, so you're going to put the negative 2 up front, and then that complex number goes behind it, and it's positive, so you'd put plus 2i square root 3. And that's as far as you can go. You can't actually simplify that because those are not the same type of number. Okay, so then that's what you get here. So now to solve this one. Same thing. Got to get the x by itself, so I'm going to have to subtract my 2. So 2 minus 2 is 0. My x comes down. And then same story here. These will not combine because they're not the same. So you take your real number and put it first. And then your imaginary number, or what's called a complex number, goes behind. So you've got negative 2I square root 3. Okay? So notice you've got 2 answers, but both of these are imaginary numbers. Okay? So there we go.